multiple linear regression, right? Samir,
Yes.
so the last class, which is multiple linear regression project. Okay,
Okay. Okay.
so now we'll try to be cover the same thing. I mean, the continuation of that particular project.
Okay.
So the corresponding project documents and data sets, which is available in my local computer, sorry, in my Google Drive. So I'm just going to that one, and the project is bike sharing for medical insurance charge prediction. This is the project we are working on it.
Okay.
So let me go for look that one whether the same that project or different project. Mhm. So am I uploaded the corresponding documents or not? We'll see. So have you able to access the recordings in all modules? Samir and Akash.
Yes, but I didn't see a recording from yesterday.
Yesterday we have not having any session.
Oh, okay.
Okay, this is the project. So the project is multiple linear regression project. Oh, okay. We were not discussing anything. Okay. Okay. I think I'm not uploaded the project information, only theoretical part.
Okay.
Okay, and this is the recording, and this is the documents I have.
And
Yeah, yeah. Just I'm opening my project. So I think this is the things I already explained in our previous session. And so this is the data we are displaying first 10 records, and I'm just showing you some kind of the relationship between dependent variable and independent variables. Okay, and I check with is there any kind of missing data with help of matplotlib we seen it, and with help of the correlation matrix, with help of the heat map, we can display the relationship between the independent variables versus dependent variable, as well as dependent variable versus dependent variables. Okay, so we are checking the assumption of multiple linear regression or linear regression. Okay, clear. And and here your dependent variable, which is not symmetrically distributed and which is not normally distributed. Okay, so the data we are converting into normal distribution with help of the log function. So what data we have it, to that particular data we are applying the log transformation. Then the data what we have it, which is on a symmetric asymmetric data or skewed data, this can be converting into normal distribution. That is the use of the log transformation. So we have a transformation techniques. With the help of the transformation techniques we are converting in the converting into normal distributions. So this Willon plots will help you the min and max, median data, and quartile. I mean phi summary data, right? That phi summary data we can display with help of this Willon plots actually. Okay. So here, this male and female, what could be the charges here? Okay, the minimum charges of the female is it's below valid. Okay, so it could be which is starting with 1,000 or 10,000. Okay, the highest it would be 70,000. So male and female, the charges it could be a same. Okay, but when it comes to the smoker, the medical charges it could be very high when the person having the smoking. Okay, and the starting and who are having the no smoking. Okay, those guys are not, it's not charging more. So that is the use of the villain plots. Okay, and here we are going for the box plots with children's and charges, and here we are giving the color coding is okay, male and female. And so we are plotting the box plot for the x data could be the children's, and y data it could be charges, and HUE means the data we are whatever the data we have it, the data we are splitting with based on this HUE only. Okay, so here this is a blue color things, it means that it's female things, and this color it could be male things actually. And when we see that box plot, there are lot many outliers out there. Okay, what I told you actually, so if we have a data which is outliers, maybe you won't get that good result, you won't get that better accuracy, right? Or else you won't get that best fit model. So how you deciding that is there any outliers? See, this is the points we are calling it say outliers only. The points which is greater than this line or less than this line, that we are calling it outliers. Okay. So it could be this data it could be outliers. Okay. This data it could be outliers. So that outliers we need to handle it. That outlier treatment we need to do it. Okay. And meanwhile, we are going to be display the region wise charges and male and female things you're showing over here. Okay, and so in the regions almost same for female and male, the charges it could be the same. There is no difference. Okay, there is no much difference, and this is the plot indicating that in age there are different. Now, in age also, okay, in between 10 to 70, okay, there could be some people smoking and non-smoking guys are there, right? So the smoking and non-smoking guys, okay, the charges it could be the smoke in the age as well as smoking and non-smoking, whether it is depending on the charges or not. This is multiple linear regression, right? So that's the reason we are taking the multiple things, multiple variables. Okay, and we are plotting over here. Okay, this age of the no smoker is charges, it could be linearity, it could be linearity. And if the smoking is no but the charges it could be low, but it could be somewhat linearity could be there. And in the age, and age wise, and if the people having the smoking habit, then the charges it could be high and it could be linearity as well. Okay, you can see smoking versus BMI. Okay, and in the age group people in between 22 to 40, if it is the no smoker, then that means what, it is not much depending on the charges. But if the people having the smoker and if the BMI, it could be positive linear relation. See the graph, it was increases. If your BMI is increases, then the smoke, if the people having the smoking habit, then the charges it could be high. This kind of analysis we can understand from this particular graphs. Clear?
Clear.
Too much neck pain, I don't know why. Okay, so most of the time we have to spend to understand the data. See, from the left plot, the minimum age person is inserted in 18 years. There is a slab in a policy. Most non-smoker take first and second slab, right? For smoker policy, start second and third slab. Okay. So slab it was charges very high, right? Second and third it could be charges high. if and so body mass index measures the body of based on the weight and the height. Okay, applies to adult men and women. The minimum BMI is 16 kgs per meter. Okay, mass. Okay, and maximum up to 15 kgs. Okay, and so here there could be some kind of relation BMI, and when the guy is having the smoking habit, then charges it could be increases. Now, data processing is the concept. So before we are doing the data processing, we cannot uh, learn. We cannot apply the machine learning. Okay, so might if we have some kind of categorical data, so we cannot apply the machine learning algorithms on your categorical data. Okay, so that's the reason what you should do, that categorical data in the sense character data. That character data you should be converting into the numbers format. Okay. Just 1 second. Okay. So if you want to be convert into categorical data into the numbers, so there is three different methods we are going to be using. One is the label encoding, second one is the one hat encoding, third one is the dummy variables. Okay, so these three methods can be used for to convert your categorical data into the numerical data. It refers the transforming the word label into the numerical form so that algorithm can understand how to operate them. So here one hat encoding is representation of the categorical variable as a binary vectors. So here it is a word, the word it was simply converting in the number. But here the word which is converting into the binary vector actually, which allows the representation of categorical data to be more expressive. Okay, so it was giving the more intuition actually. So when you are using one hat encoding, so there could be some high meaning. Okay, the first requires that a categorical value mapped to the integers, that is label encoding. Then each integer value represented as a binary vector, that is also zero values expect in the index of integer, which is marked with a one. Okay, and dummy variable in the sense, so we are going to be creating the new variables which are dummy, and you can able to delete your categorical column after you're converting into the dummy variables. So so here if you want to be converting into the if you want to transfer your number into the categorical data, then what we can do, we just go ahead, take the these are the columns if you want to work for it. Okay, and within this one, and what are the categorical, these are the these are the columns are the categoricals. Okay, these four columns I'm taking as a categorical data. So this we are not taking actually the data which we have it categorical form, that data that columns we are taking as all columns into one location, and we are just giving to the get dummies method to these columns, and it was newly generated data which is df underscore encode. Okay, so that all data this df underscore encode, which is having the data of numbers only. Okay, even you can able to go for uh, you know display the data, it was everything could be in a number format. Most of the time we are going to be using the dummy variables or else label encoding or one head encoding. Okay, so your box cox transformation. So once if you've done numerical format, then we can go for understanding that box Cox transformation. Box Cox transformation is a way to transform non-normal dependent variable into the normal shape. So I already told you, right, when you're applying the log, then you're not, if it is not a normal distribution, then it can be converting into the normal distribution. The normality is the important assumption for the many statistical techniques. So if your data is not normal, applying the box Cox means that you are able to run a broader number of tests, that all that we need to perform the transformation to find the lambda value, apply the rule is shown below. This is the function for the box 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 cox transformation. So anyway, we can have a function is box cox, which is available in a scipy, and we are just taking all and we are just taking the charges information, and we are applying the lambda value is 0.05, then which is having the ca values and lambda value. Okay, and this ybc, this is y variable f, this ybc values. Okay, so anyway, you're converting into the um, you're converting into the you're trying to be converting to the box cox, I mean transformation. Then simply we are applying that log transformation. This is the two different ways we can do that. The original categorical variables are removed, and also one of the one had encoded variables column is a particular categorical value is dropped from the column. So we complete the three encoding steps by using the dummy function. So simply whatever the data we have it, that we are converting into the okay normal distributions. So normal distribution means it's a very simple thing, guys. If data could be, if you're displaying the frequency table, then the data it could be displayed something like this particular graph format, that we are calling it say normality. Most of the statistics could be follow the this normality assumption only. Okay, so that's the reason if your data is not normal distribution, then we would like to go for apply this method, and you are going to be converting into the normal distribution data. Okay, from the non-normal distribution to normal distribution. So before we are applying any machine learning algorithm, make sure that for creating the model we should have the training data, and for testing, for validating, we should have the test data. So if it is not available, we have a function is there, train test split method. This is the method we are going to importing from model selection, and we are taking the x data and except charges everything I'm considering as the x, and only charges we are considering the y, and we are just providing the x and y, and 70% it could be the test train, 30% it could be the test. So the reason is that test size here 0.3 I mentioned. 0.3 means 30% could be the test data. So your x test and y test randomly you're selecting from the okay data set, and it could be the 30%. Then simply you're going to be building the model. For building the model, so step number one, we are going to be adding the x0, it could be the 1, right? So because of the features are which is started with x1 x2 x3, right? But but coefficient b0 we don't have anything. So corresponding b0, the x0 it could be the one I'm considering. So that x train 0 I'm adding the ones with a shape of we are adding the uh, we're adding the one to your x train as well as x text. Then after you're doing that multiplication with the linear log inverse this function, right? X transpose x inverse minus 1 means it's inverse. So that np lin all env, this is the function can be helpful for okay inverse of the matrix. Okay, and so we are doing the multiplication, right? X transpose and x, so that MUL means matrix multiplication. X train 0 dot T means transpose and X train. And this is the thing, the result of this thing, we are doing that inverse. And the result of this thing, we are multiplication with your multiplication with what? Your multiplication with X transpose and Y. So that X transpose and the Y, you're doing that multiplication, and this entire thing again, the result of the X transpose Y, we are giving the you're multiplying with the inverse of this thing, so that this entire thing and this one could be multiplied to each other. Okay, so this is the function only we are implemented with help of the NP. So this is the way you are created the theta. So manually we are creating, guys, we are not applying the linear regression. Okay, directly we are going to be creating your best fit model with help of the sum square least square method that I already explained your theoretical information. Okay, so now we calculated the theta, right? So now here what I can do, I don't know how many number of columns we have it. Okay, so that we are taking the range of columns. So here I have the shape of one, shape of, in the sense the shape, it can be written the number of rows and number of columns. Okay, so we are creating the parameters, we are creating the parameters, theta 0. Okay, and we are going to be creating the parameters and intercept. So columns and list of columns, and we are creating the new data frame. So this is the data frame. Okay, parameters theta 0, theta 1, theta 2, and this is the column. Okay, this is x0, age, and BMI. This is the columns. Okay, this is the column, right? Yep. So first thing, it could be intercept. Rest of the things, it could be your column values. Okay, x dot column dot values, in the sense we are just written the columns names. And this is the this is the theta value. So you have already theta data, right? So theta values, and parameter columns, and theta values. So with this one, we are going to be creating the new data frame. The data frame is parameter underscore df, and to this one we would like to go for giving that x scikit-learn theta values. So just comparing actually. So with your own we are creating, as well as directly. So this steps and this step, we are creating our own. This is the these two steps we are going to be creating our own, right? Instead of this one, we have a linear regression function is there. Directly to this particular function, if I'm providing the x train and y train, you don't need to do that okay, multiplication, transpose, this, you don't need to do this step. This is your own, you are going to be creating your own model. Okay, and you're going to be creating the linear model with the direct function. Okay, from the scikit-learn, if I'm directly providing that linear regression and I'm providing that x train and y train, you don't need to be creating that, x and you don't need to be add the constant, and directly we can provide it. X here we don't need to provide that x0. Okay, automatically the scikit-learn will take care about it. After that one, we are taking the theta values and lin underscore reg dot intercept value, and and constant values we are taking. This is your theta values. Okay, this is intercept, and this is your coefficient values. So with help of this one, we are adding, concatenating your previous parameter underscore data frame. So this is the data frame which is having only parameters, columns, and theta. But whatever the theta values from here, we calculated this scikit-learn theta values, we are added to, or we are joining with the previous data frame. So careful observe here, by manual calculation, by linear regression calculation, is it same theta values or not? So that is the importance of this scikit-learn library. So if we have a knowledge on scikit-learn, you don't need to be go for creating this kind of functions. Okay, you don't need to implement the mathematical functions with your own logic. So with your own logic, we don't need to be implemented. Okay, if we go for using this scikit-learn, so the result could be correct results only we are going to be getting. Clear or not? So this is the way we would like to
Clear,
go for building the
clear.
best model. So my model is validated whether my model is good or bad. For that one, we would like to go for finding the mean square error and R square. So this is the way we would like to go for evaluated, right? So model evaluation steps I already told you: mean square error, root mean square, adjust rod square. Those things we seen it, right? Okay, so this is normal equation, and so this is your mean square error function. Okay, so we're just displaying the mean square error and R square value. So here the mean square could be very very small, and my R square could be the approximately 80%, which means that, and this is the steps also again we calculated our by hand with your own Python knowledge. With your own Python knowledge, we are going to be creating this one. And if we already know that function, okay, formula, that formula we are going to be implementing. Or else, inside of this scikit-learn, we have the matrices libraries there. So inside of it, a mean square error function is there. To this particular function, directly we can providing that your prediction values and your original values, then automatically you will be getting the mean square error. And if you want to get the R score, then we have a function is score function is there. Simply we are providing that score x test and y test, then you will be getting that R score value. Okay, this R square value, it could be the same like what we are getting here, yes or no? And this mean square error value what we are getting here, it is equal to this one or not? So this is the uh, this one and this one, both are same only, but here we are using the predefined functions, but here we are implemented our own functions. Okay, clear? So this is the model evaluated. Model validation, I would like to go for validating the model. And if we have VAF value, it could be the more than the 5. That means there could be some kind of more multicollinearity. Okay, more collinearity. And so if the data which is having in between the EF value which is in between 1 to 5, which is moderator correlation, and if it is less than the, okay, so if it is VAF value, it could be the more than the 5. That means there could be high multicollinearity. Okay, those things we can able to go for check here. This is the assumption. So what assumption we would like to go for? Linearity checking the linearity assumption, right? So the linearity assumption for what to what? Actual and predicted. Okay, so we would like to go for, we are plotting the two graphs. One graph is for linearity between the actual and predicted. Yes, it's linear. And we are going to be checking the residual normality. So this is the graph which is normal distribution or not? Yes. And is there any kind of multivariate is normality? Okay, so residual normality. This is QQ plot, which is this red color line and this blue color. If it is the same, then it could be normality. But there could be some kind of variation is there. So I can say that the model is assumptions are not met. Okay, homoscedasticity in the sense the variance, the error could be, the variance of error, it could be constant, but it was reduced, right? So your EF value which is less than the 5 only. Okay, that's not a problem. So here what assumptions are following here, I'm explaining. In our model, actual versus predicted curve is so linear assumption fail. So you just see here only uh, there is two parallel lines are there. Just see, here we have, this is the, here we have some data, and here data it was distributed, right? So this is not normally normal, it's not linearity. Your actual and predicted which is not following the normality. Okay, and moreover there could be some kind of skewed could be there at the right side, right? So, and normality in the residual also not met. Okay, so the assumptions are meeting or not. The residual is 0 and residual error plot right skewed, little bit of right skewed, and QQ plot showed the value, log value is greater than 1.5 trends to increase. And see, the plot is exhibit heteroscedasticity. This kind of thing, this is not a homoscedasticity. It could be heteroscedasticity, right? So error will increases after certain point. See, the error it was increasing, right? So error could be constant. And variance influence fracture value less than 0, so no multicollinearity. Only one assumption is met. Only one assumption is met. No multicollinearity problem. There is no multicollinearity. That is the only one assumption is met. So rest of all assumptions are failed. Okay, because of this one, we can concluding that whatever the model, even you are getting the 77% of accuracy score, we are not able to finalizing this model is good. Clear? Most of the people in interview question, this is the question only we are going to be getting. How you would like to go for finalizing your model? Most of the people what they will say, I just check that mean square error, and I already checked that r square value, my mean square error is very very less, but my r square value is very high, so that my I'm going to be finalizing the model. If some kind of answer if you are saying, then you won't hire you actually. Okay, so we have to go for validate and we have to go for validate your model with help of some kind of assumptions. The assumptions are linearity, normality in the residuals, and and heteroscedasticity and multicollinearity, and this kind of things we would like to go for. This all assumption we need to go for check, or we need to go for test. If all tests are passed, or if all assumptions are passed, then your model is good, and whatever the model we are finalized, or whatever the score we are getting, that is correct. The model is good. Okay, if these assumptions are not met and you're getting the high score, that means your model is not correct. That's what my final that's what I'm finally trying to tell you. Okay, now what I would like to go for, I would like to go for download this. Okay, and this project I would like to share with you and go on the practice, or go on the no download that one and execute that each and every statement. And I would like to give you a project. The project is car price project. You would like to go for predicting the car price. So based on the fuel type, body, wheels, and based off on this one, we would like to go for find the car price. Okay, this is the project I'm giving an assignment. I am downloading this CSV file and I am sharing with you. Okay, and what you should do, I am uploading this project. First, try to execute the medical insurance project or medical insurance charge project. After that one auto importers.csv1 is there, right? That project we should do it. Okay, okay, uploading. Yep, done. Yes, so here I am giving the.
Excuse me.
Yes,
Excuse me. What do I have to do with this project? Do I have to use Python for this project or
it's a Python
no?
project.
It's a Python project. What do I do with this?
As of now, whatever I explain, that same thing you should try to be execute and try to understand that thing. Okay,
When is the
On which platform we
just one
have to
second. Just one second. I would like to modify this file name. Okay,
when is the deadline?
Monday.
Thank you.
See, this is the car phrase CSV. This is the data set. Okay, how I did this project. Okay, how I did this project. In the same way, we can try to be go for do the car phrase prediction. So this medical cost billing project, okay, I explain with my data set. This is the data set which is available in my current working directory in my Google Drive. Okay, so this is the project, right? So this is my code and this is my data set. Okay, this is the data set which is taking into this particular Python. This is the Python program which is taking, and this all steps I'm doing. And by the time I'm understanding that what is happening inside of the data, okay, these are the steps I did it, right? This is the libraries. These are the Python libraries. Okay, I'm executing each and every Python statements, and I'm understanding that results. Okay, in the same way, what you should do, I uploaded the car underscore price CSV file. You can download the CSV file, and how I did that, inside of the zip file we have that code will be there, and as well as corresponding a CSV dataset file is also there. Okay, so first do this one. First execute that what is there inside of it. After that one, after you understanding that medical charge prediction project, then go for do that car price prediction. Okay, clear? Clear or not?
Uh, can you say that where I have to fetch that file in Google Colab? How
No,
to fetch?
you should go for do your local computer. If your local computer is Python is not there, then we can try to be open from the Google Colab. Take time, try with multiple sources. Okay, if you're facing anything, you have my number, right? So you can message me. I will try to be answer your questions. Okay.
Excuse me, what time are you available on weekends?
I'm not available for weekends for anymore, but if you have any kind of questions, you can message me. I can reply you. Okay.
Thank you.
Bye. Come for Python session.
I have a question.
Yes.
Did you have SQL and Tableau session today?
Yes, it's done.
Can you post it? I don't see the.
I will upload it. Okay.
Okay. And did you start the statistics class or not yet?
Okay, I will upload it.
Okay. I have another question. When are you going to start the statistics class?
I will tell you. See, I was little busy with other modules, right? So once I done,
Okay.
then I would like to start the statistics sessions.
Okay. Thank you.
Yeah.